This is Norway, a country where mountains and fjords have been fighting for space for centuries. The terrain is so shredded by water that even building a simple road is a nightmare. But the Norwegians thought there still wasn't enough water, so they decided to split one of the mountains in half and hide the sea inside. They'll have to pull out over 106 million cubic feet of rock, spend 800 million euros, and drill through the mountains with inch-level precision, or it'll all collapse. The result? A 1-mile-long tunnel, the only structure of its kind in the world. Nobody has ever done anything like this before. Why do this madness when there's already water everywhere? And what will happen when the sea actually moves inside the mountain? Let's find out. Deadly waters. On the map, the Norwegian Stad Peninsula looks like a harmless piece of land jutting into the sea. But sailors don't see it that way. They flinch at the name as if remembering something bad. And there's a reason for that. Here, the sea does things it's not supposed to do. It changes every minute, as if someone were manually flipping a switch. This is a place where the sea gets more unpredictable than any weather forecast, and where decisions are sometimes made not by maps, not by the captain, and not even by common sense. Stad is a geographical trap. Because of the shape of the coastline, ships have to head out into the open sea, with no chance to hide in fjords like they do elsewhere. Worse yet, storms here never really end. They just take breaks. Even when the wind dies down, the waves keep rolling for several more days. Why does that happen? This is where two different wind corridors collide. North Atlantic cyclones strike the coast head-on without dispersing. Sailors and researchers even say that near the peninsula, waves can reach 100 feet. And these waves are pure chaos. Since two seas meet here, the North Sea and the Norwegian Sea, and the depth is shallow, any wave can suddenly hit a ship from the side. And given their size, all you can do is wait and hope for a miracle. Feel the danger of this route? Let's add a few more details for a clearer picture. Since the end of World War II, more than 30 people have died, and over 45 major incidents have been recorded in the Stad area. If nothing changes, the number of victims will only keep growing. Keep in mind it's Norway we're talking about, a country where the sea isn't about romance, but economy, logistics, and fishing. These aren't gentle sightseeing routes, these are daily highways for large vessels. For instance, the country is one of the world's largest seafood exporters. In 2024 to 2025, Norway supplied around 3 million tons of fish and other marine life to 150 countries. And right here, where people earn their living, lies some of the most dangerous waters on the coast, right along the shipping routes. The result is a high chance of disaster. For example, in January 1969, during a severe storm near Cape Stad, a trawler found itself in chaotic crosswaves. The ship was relatively small, and the unpredictable wave patterns led to its wreck. The whole crew perished. And this problem isn't limited to trawlers. Along the shore lie dozens of small villages. Their residents travel to towns by ferries that cross the same deadly waters. Yes, sometimes they manage to catch a weather window, but that window isn't constant. It might last 4 hours, or it might be only 30 minutes. Sailors say the most honest way to describe navigation there is a lottery. You can have a perfectly functional vessel, a great crew, modern electronics, even set out during calm weather, and still find yourself in a situation where the sea decides everything for you. In short, the waters around the peninsula are the bottleneck of Norway's entire maritime activity. And of course, the country has spent decades thinking about how to get rid of this maritime Russian roulette, because life and economy shouldn't depend on luck, shouldn't rely on a cyclone turning the right way, shouldn't bow to the whims of the most dangerous stretch of their coastline. Sooner or later, a solution had to be found. Something just as bold and wild as the sea itself. Something that would make the sea itself retreat. A sea inside a mountain. When it became clear that it was impossible to bypass Stad safely, the engineers decided not to fight the sea, but to build it into the mountain. That's how the project of the Stad Ship Tunnel was born, a 1-mile passage running from shore to shore at the most suitable spot on the peninsula, where the distance between the waters is the smallest. Though that doesn't mean there's little work ahead. On the map, it may look simple, a thin line between two coasts. Yet behind that line lies the largest mountain cutting operation in Norway's history. Here, they literally have to cut through the land. In total, engineers expect to remove about 106 million cubic feet of rock. It's like carefully taking apart an entire small mountain, but strictly mathematically, with precise calculations of the corridor's geometry. And there are other details that show the scale of the work. To haul away everything carved out of the mountain, trucks will have to make 750,000 trips. Most of the dirty work will be done using traditional methods, drilling and blasting. Dozens or even hundreds of holes are drilled in the right places. Charges are set. The rock is broken up and taken away. It's an old and proven method, one that quickly clears out thousands of tons of stone. But this tunnel won't be blasted in the usual in one side, out the other fashion. Even here, the Norwegians chose a more subtle approach. The work will go from top to bottom, layer by layer. First, they'll open the roof of the future ship corridor, shape it, check every line. Then they'll move to the next level, rechecking the profile. And so, layer by layer, they'll go down until a full-scale rock channel is formed. It's like performing a surgical operation on the mountain. Not one brutal cut, but a sequence of precise, measured moves. Of course, blasting never leaves perfect geometry. There will be jagged edges, slight shifts, small bumps. But for a tunnel that'll be filled not with air, but with water, such imperfections can create excess turbulence. So the Norwegians add another tool, diamond wire cutting, which doesn't break the rock, but literally slices it with surgical precision. It's used to bring the walls and floor to their final design profile, making the tunnel's interior as smooth as possible. That's the final stage of construction. You can't just punch a hole through a mountain. You have to build a tunnel where ships can pass without feeling like they're being launched off a ramp into a stormy ocean. Every fraction of an inch in the profile matters for safety. Every cut line determines how the water will behave in the future. The tunnel will be massive. Picture a passage carved into solid rock, big enough for a full-size ship to sail through. There was never a chance for it to be anything modest. The height will be about 121 feet from the water surface to the ceiling, the width around 87 feet, and the depth up to 39 feet. And here's the most impressive part, how the tunnel will actually become navigable. Before opening, it'll still be dry, the space once filled with heavy machinery and drilling rigs. On both sides, temporary dams will keep it that way. Heavy steel barriers separating the tunnel from seawater. While they stand, crews can run final inspections, install equipment, mount lighting systems and navigation sensors. Only when everything is ready will the final phase begin, the flooding operation. It will proceed gradually, under strict supervision. Engineers have calculated the process down to the tiniest detail. Water pressure, inflow rate, temperature differences. The flow will be released through special valves to avoid sudden stress on the walls and arches. It's crucial for the water to enter evenly, otherwise the risk of cracks or deformation is too high. When the water level inside matches the sea, the dams will be removed. That will mark the actual opening, the moment the tunnel connects with the ocean. After stability checks on currents and safety systems, ships will be allowed in for the first time. The architecture of the tunnel is handled by Snuhetta. It's the practice behind Oslo's iconic opera house, so something unique can be expected. For instance, the entrances aren't plain concrete arches or smooth portals, they're stepped stone terraces. Each step is cut from local rock. Visually, it looks like a natural ledge, a clean mountain cut, just a bit tidier than the rest. This approach isn't just about aesthetics. The terraces help absorb wave energy, reinforce the shoreline, and hold the tunnel structure during strong storms. The sea around Stad shows no mercy, and the architects understand. If the shape isn't sturdy and logical for nature, it won't last. The walls will be reinforced with shotcrete to withstand pressure and vibration from passing vessels. There won't be spotlights, but continuous LED strips running along the tunnel. They create soft, even illumination and double as a navigation guide. Captains will steer by following the color line. In one-way traffic conditions, that's crucial. Every passage happens on schedule, under control, with no room for chaos. Outside, the tunnel will have its own supporting infrastructure. The most important part, the vessel traffic center. It'll operate like an air traffic control tower. Operators will monitor vessel movements, weather conditions, and grant permissions to pass. For a region where storms are routine and visibility often drops to zero, this isn't a luxury. It's what guarantees the tunnel solves a problem rather than creating one. Next to the western portal, a viewing platform will be built. A new road will lead there, offering a direct view of the tunnel entrance. The idea is simple, to show how ships literally disappear into the mountain. Inside, everything necessary for a short visit will be arranged. When the Stad Ship Tunnel project was first approved, it looked like a perfect example of Norwegian engineering pragmatism. In 2024, the budget was estimated at 5 billion kroner, or about 426 million euros. A hefty sum, but let's not forget, this is a tunnel for ships going through a mountain. At the time, everything seemed calculated. Geology checked, contractors selected, estimates verified. But within a year, the figures nearly doubled. By fall 2025, the cost was projected at 9.4 billion kroner, roughly 808 million euros. The overrun became more than just a bookkeeping issue. It put the whole project on hold. In October, the government decided to temporarily freeze the tender process until ways to cut costs were found, but the parliament disagreed. It intervened directly, demanding that the Norwegian Coastal Administration continue talks with contractors to negotiate lower prices. Major industry players are involved. They've been given until the end of February 2026 to recalculate the budget. If all goes well, the new budget will be approved in spring and construction will begin mid-2026. Then the tunnel can finally start turning from a project on paper into a real passage through the mountain. And both the country and the region will gain a number of very tangible benefits. Norway's Golden Age. Imagine a morning at Stad, a gray horizon, heavy waves, wind tearing foam off the surface, and somewhere beyond the cape, a ship stands waiting. It's been 3 days of storm already. The skipper looks at the radar, checks the forecast, but there's no way out. Sailing along Stad right now is impossible. And it's exactly for moments like this, for the chance not to wait, that Norway's digging a tunnel through the mountain. When it opens, coastal traffic will never be the same. Right now, 20 ships a day go around Cape Stad. And that's in good weather. After the tunnel opens, there'll be several times more. At the planning stage, Norway says the new route will handle from 60 to 100 vessels. Fishing trawlers, cargo ships, ferries, tourist boats, all will be able to pass through the mountain without waiting for the wind to calm down. The tunnel's capacity is designed exactly for that. 100 ships a day, a steady flow, like a highway, only under a layer of granite. Even on a good day with no storm and calm seas along the peninsula, few would probably choose the longer route past the coast. After all, the total distance will be 35 miles shorter. Not an enormous number, sure, but who wants to spend that long in an unpredictable zone? There is, however, one problem. The new passage will have one-way traffic. Yes, it's a serious limitation, but there's no other way. Just imagine how much more effort, money, and time it would take to make a two-way tunnel. In the new tunnel, ships will go north for 1 hour, then south for the next. The flow will be managed by a vessel traffic center, essentially a marine air traffic tower. On their screens, operators will see every vessel, its speed, and its transit time. Each one will have its own slot, its own time window, so there will be no jams or random encounters in the narrow corridor. This system wasn't invented from scratch. Before construction, the Norwegians ran dozens of tests. First in tanks with miniature ships, then with computer simulations. They tested how a 459-foot vessel would behave in a narrow passage where only 8 feet remain on each side. Scientists searched for the optimal speed, fast enough to stay maneuverable, but not so fast that it would create excessive wake. They also studied what it would feel like, the transition from open sea into a concrete tunnel where the engine's echo bounces off the walls. The results of these tests turned out to be more than just engineering data. They became proof that the tunnel would be both safe and efficient. When a vessel doesn't have to spend hours and tons of fuel sailing around the Cape, the savings become tangible. For small ships, simulations showed about a 60% reduction in fuel use, and for larger ones, about 30%. These aren't numbers from a press release, but calculations based on real routes. The fuel that used to burn away in the fight against the wind will now stay in the tanks. Fewer emissions, less wear and tear, lower risks. It's also worth mentioning trade, since the country relies heavily on maritime transport. Remember, the tunnel's height will be 121 feet, width 87 feet, and depth up to 39 feet. That means almost no container ships will be able to pass through. Let's take, for example, the smallest class of such vessels, the Panamax, which carries around 7,000 TEU, or 20-foot containers. It has a width of up to 106 feet. See, even the tiniest representative of the container ship class doesn't fit inside. Naturally, larger ships won't stand a chance either, so unfortunately for the global economy, international trade won't really benefit from the new Stad ship tunnel. Still, Norway's a country of coastal trade, carried out by small and medium-sized vessels and ferries. All of them will fit, which is why it's estimated that the new route will handle up to 81% of current sea traffic. When the tunnel opens, it won't just be a logistics corridor, it'll become a place people actually want to visit. In Norway, tourism has long thrived, not on souvenirs, but on natural landmarks. People are drawn not only to postcard-perfect fjords, they're also fascinated by human engineering surrounded by raw wilderness. The Stad Ship Tunnel is a new attraction. How can you cut through a mountain in such a way that ships 131 feet tall can sail inside? It's bound to become a new Norwegian wonder. Tourists love that kind of thing. What's more, the new tunnel will expand the map of tourism. The region already offers stunning views, beaches, and world-class surfing, but getting there's been difficult. This is one of those cases where new infrastructure doesn't just make the route faster, it opens the door. Once the route becomes stable all year round, more cruise ships, more expedition vessels, and more private yachts will be able to come here. Tourism in Norway is all about people who travel on purpose to see a place where humans and nature come to an understanding. The Stad Ship Tunnel will make such encounters more frequent and more accessible. By the way, remember they're planning to take an enormous amount of rock out of that mountain. To be exact, 106 million cubic feet. It might seem like just waste, but it's actually going to be put to good use. In fact, some of the material's already been allocated to several projects. In Malloy, a town not far from Stad, about 11.5 million cubic feet of rock from the tunnel will be used to build a new city district. It'll have commercial buildings, a hotel, maybe even a water park. Basically, the tunnel will produce not only a passageway for ships, but also the material for a whole new piece of the city. The remaining rock will go toward reinforcing the shoreline and expanding port areas to support the region's fishing and maritime industries. This isn't waste recycling, it's turning construction leftovers into investment. Yes, there are a lot of upsides to the Stad Ship Tunnel. However, can we even be sure Norway will finish building it? The project is incredibly complex after all. Well, everything will most likely work out, if only because Norway's long been known as an expert in the toughest and most extreme types of construction. The country of tunnels. We've already talked about how Norway is a country surrounded by a crazy number of cliffs. That's exactly why tunnels here aren't some kind of exotic thing. They're a normal, boring, everyday part of life. Norway is the kind of place where tunnels are as standard as regular highways elsewhere. According to Statens Vegvesen, there are now more than 1,100 road tunnels in Norway. About 50 of them are underwater, roads that run beneath the sea, connecting fjord shores directly instead of making people take long detours or rely on ferries. On top of that, there are another 900 railway tunnels across the country. Even small rural roads between villages often go through tunnels. You can be driving on that road that links a settlement of 400 people with another of 200, and there'll still be a tunnel on your way. Not just one, more likely 2 or 3. Because otherwise, in winter, it's simply impossible to get from point A to point B. Well, you can, but it's always risky. The goal here isn't to make it pretty. The goal is to make it livable, so people don't feel cut off from the world every time the wind, snow, and rain come. So yes, you get the idea. There are a lot of tunnels. But to understand why a new navigable canal project can actually be done, we have to look at Norway's record holders. The tunnels that prove the country knows how to build things that are truly one of a kind. And that's something Norway has absolutely mastered. This isn't just a country of tunnels, it's a country of tunnels that'll blow your mind. The Lærdal Tunnel stretches for 15 miles through the mountains. It's the longest road tunnel in the world. It connects Lærdal and Arland, bypassing an old mountain road that used to become impassable in winter. Driving through takes about half an hour without daylight, and that's why they came up with a special psychological relief system. Every 3.7 miles, there are large, brightly lit halls bathed in soft blue or amber light. They're designed not only for rest, but also to help the brain keep its sense of direction. Fresh air is supplied from both ends, and in case of an accident, the ventilation system automatically reverses flow. Everything here is built to make you feel calm underground. This tunnel proved that infrastructure can care not only about safety, but also about psychology. Because when you're driving half an hour under a mountain, your mental state matters too. Then there's the Eiksund Tunnel, the world's deepest underwater road tunnel when it opened, and it held the title until 2019. It lies 941 feet below sea level and runs for 5 miles. Building it was a challenge, not only because of the water pressure, but also due to logistics. Concrete and steel had to be delivered along narrow coastal roads, then lowered down shafts where humidity and temperature were nothing like on the surface. At this depth, physics works differently. The braking systems of cars have to handle a constant slope, and the ventilation must deal with exhaust that wants to rise but can't. That's why they've installed powerful variable speed fans and gas concentration sensors every mile. This is the Ryfylke Tunnel, opened in 2019, the longest underwater tunnel in the world, stretching 9 miles. It also beat the Eiksund Tunnel in depth, going 958 feet below sea level. The tunnel connects Stavanger and Tau, replacing the ferry line that half the region used to depend on. And then there's Rogfast, a Norwegian tunnel that takes the concept of an underwater road to a whole new level. It'll reach about 16.5 miles in length with a maximum depth of around 1,300 feet below the sea. And we're not talking a bit deeper than usual. That's nearly 330 feet deeper than the Ryfylke Tunnel, which currently holds the world record. The Norwegians aren't just digging deeper, they're creating a whole new class of tunnels. Construction proceeds in stages. Rock is removed through temporary shafts, and the temperature and pressure below already require special working conditions. The drillers go down there like divers. When Rockfast opens, it won't just be the longest and deepest tunnel in the world, it'll be a symbol of how far Norway has gone in mastering the underground. Rockfast will have 2 tubes, one for each direction, with cross connections for safety. If something happens in one tube, traffic can be switched to the other. This isn't one tunnel, it's a full underwater system. Inside, there will be advanced ventilation, air monitoring, fire compartments, evacuation corridors, and automatic monitoring systems. Because when you're driving under the sea, almost 1,300 feet deep, everything has to work flawlessly. Rockfast is infrastructure evolution, a new benchmark of depth and scale. The craziest part of the project is a junction 853 feet below the sea, underwater. And not just one, 2 circular roundabouts will be built at that level to branch off towards Kvitse, an underwater traffic circle beneath the ocean. Sounds like sci-fi, but it's actually being built. In fact, even the smallest tunnels in Norway tend to break records. Only they're not meant for trains, cars, or ships. Take the Fyllingsdalen Tunnel in Bergen, for example. It's 1.8 miles long, making it the longest pedestrian and bicycle tunnel in the world. It runs under Mount Lavstakken and connects 2 parts of the city that used to be divided by busy roads and steep hills. Now the trip between them takes just 10 minutes by bike along a flat, quiet, dry path. For Bergen, where it rains nearly 2/3 of the year, that's not luxury, but a necessity. Inside, it doesn't feel like a typical underground structure. The walls are painted in bright colors, the lighting is dynamic, the light shifts softly, creating a sense of movement and safety. There are rest areas and small alcoves with benches. No engine noise, no exhaust smell, just the sound of footsteps and spinning wheels. The project became part of the city's green mobility program and a symbol that underground spaces in Norway are not just about transport and infrastructure, but about everyday human life. But something's missing. For instance, a tunnel that's truly one of a kind. The Sognefjord Crossing Project is one of Norway's boldest ideas, something that sounds almost like science fiction. To build a floating tunnel beneath the surface of a fjord. It's impossible to carve a regular tunnel under that much rock, and a bridge wouldn't work either. The strait's too wide and the wind's too strong. So engineers came up with a third option, a tunnel that doesn't rest on the seabed, but instead floats inside the water itself. The structure will consist of 2 parallel tubes, each about 2.5 miles long, suspended from pontoons and anchored to the bottom with cables. It'll lie roughly 65 to 98 feet below the surface, deep enough not to interfere with ships, yet shallow enough to avoid turbulent currents. Essentially, it's an underwater bridge that floats in place, stabilized by a system of balance and tension. In case of storms, special dampers will let the tunnel breathe slightly with the waves without losing stability. If completed, it'll be the world's first submerged floating road tunnel. It's meant to become part of the coastal E39 highway, the one that'll connect Norway south and north without a single ferry crossing. In the long run, it'll shorten the route between Bergen and the northern regions by dozens of miles and free drivers from weather delays entirely. Right now, the project's in the modeling phase. Engineers are testing its behavior in wave tanks and digital simulations, studying how it'll react to changing currents, pressure, and shock waves. And if a country dares to dream this big, is there really any doubt it can pull off the world's first ship tunnel? Probably not. They'll make it happen.